it has both been fun and highly informative. Like the saying will always go, those days before Corona, when I usually go to the gym once in a while, and I'll be sweating it out. Like someone once told me that there's no pain without gain, or there's no gain without pain. Which one is it? Yeah, so that is the way life is generally. We need to put in our very best into anything that we do to get the best out of it. So thanks to Vishal and Michael, they've really made I mean, everything come together, and we're able to finish strong in this year. You guys truly rocks. Thank you so much. So today we'll be having two great speakers in the house, Camden Kirkland and Sarah Kim. I'll let them introduce themselves, but briefly, Camden is currently a lead curriculum architect at Triology Education. Triology was where I started my tech journey, and Camden was my instructor. I would say he's the best instructor you can ever have, because I started as a chemical engineer. He also, I'm sure he didn't start as a developer as well, but I mean, he took a lot of us. We had diverse background in that class, and we all ended up being developer. And you can attest to it. I'm not doing chemical engineering right now anymore. So that means I loved what I was doing back then. So he was able to take me from that level to become a developer, and we really had great fun in that class. I'll let him complete the introduction when it's time for him to talk. And Sarah is the co-founder of Culture Architect. He's a technology leader at Home Depot, a business strategist, a culture strategist. She has a whole lot to her portfolio. I cannot actually mention all of it right now. And she's a great friend, really. Thank you, Sarah. She's the best at what she does. And I'm so happy to have you all here and to hear what the advice you guys have for those that are learning Python and what the future has in stock for them. So with a house full of resources right now, let's keep the ball rolling. And let me pass the baton to Camden to introduce himself. And after that, Sarah does.
Absolutely. Thank you very much, Silver. As Silver mentioned, I am one of the lead curriculum architects at Trilogy. I specifically work with our enterprise team. So if you see anything with Netflix or any other companies that we partner with to build brand new courses, I'm usually one of the people that has a hand in that. I'm also still teaching at Rice with the Trilogy boot camps, and right now I'm teaching financial technology. So if you end up taking one of the boot camps on the Rice side, you may end up with me as an instructor as well. And with that, I'm going to shut up and hand it over to Sarah.
Thank you. So I'm really glad to be here. I know a lot of you may not have met me before. I think I've only met Michael and Silver here. Um, for myself, I'm not actually a Python developer, but I think Silver got me to join y'all because in terms of development, it doesn't matter what technology you're coding in. It doesn't matter what language. When it comes to starting out as an engineer, I think it's the mindset that you need to have, and also that eagerness to solve problems, um, and also that journey that the journey that you guys are about to take was the same journey I had to take a few years ago when I did my career transition into technology. And as Silver mentioned, I do have other pursuits outside of technology, but it's all related. I see myself as the intersection between business leadership and technology. And so, yes, while I do lead technology teams at Home Depot, specifically, I lead the teams working on custom configurators when you look on Home Depot online or the in-store applications. That's what we do, but I do see the importance for that intersection between all three areas. And with I can I can help my team in their pursuit to develop stellar applications that serve customers because we are customer facing. So it's more like understanding what kind of value you can bring to the organizations you will soon join. So yeah, happy to be here and also happy to share my experience and whatever I can do to help y'all get to where you want to go to.
Thank you, Sarah. Thank you, Camden. This is great. I'm super excited right now. So let's start the ball rolling with some questions. And I want this to be as interactive as it can be. So if you have questions, let's signify by, I think you can raise your hand on this, right? Yes, so we'll take the questions just as we go, and let's go from there. I know Michael, we talked about how many programming languages we have out there. Can anyone remind me how many it is out there? It was one of our Menti survey questions. Uh-oh. Michael, how many was it, Seth? Because I've forgotten myself.
700, 700.
Wow, 700.
Yeah,
So
it's amazing.
I'm gonna direct this question to Camden. I mean, what would you say about Python versus other programming? We have about 700 of them. Python versus other programming language. Why is it important in this era?
Oh, I love this question. So I am definitely known for being one of the people that bashes on other statistical programming languages like Fortran or R. Sorry, Sarah, if you use those at work. But definitely, I think that those are great programming languages. I think that those of you that have exposure to a lot of these other languages that you might have seen in the field, like JavaScript and C# or C or any of these other things, I think they're all useful. But I think what Python brings to the table that a lot of the other ones don't is the ability to go from a concept to a production in the shortest amount of time. I can have an idea about something, start pulling in data, do an analysis, build a machine learning model, and then implement that model in a production server in the shortest amount of time possible. I think it's perfectly possible to do that in just about any language as long as you know enough about it, if you know how to make certain tools work together effectively. But when it comes to, I want to have end-to-end idea to, hey, we're making money as a business in, let's say, 3-month period, Python is what I think to be the easiest to flexibly get off the ground and running. So that has really important implications, not from a personal standpoint in terms of understanding how to program and how to build things effectively, but also from a business standpoint of, let's say you're a Shell, let's say you're an ExxonMobil, and you guys have a study that you're doing out on the field, and you want to be able to turn that study into something that is helping your teams to know what direction to drill in if you're doing some kind of directional drilling. Being able to go from, hey, we've got a bunch of geological data to, hey, we've built the software that allows us to change the direction that the drill bit is going to be heading in. That's a really, really big thing that it's hard to accomplish that with any other language with the speed at which business moves at.
That's interesting, really. Thank you, Camden. So why do you think it's important in this era to actually learn Python?
Oh, man. We are living in a time where data is being generated so fast, and that your ability to basically crunch those numbers, just first off, Excel can't handle that. I'm sorry if you're an Excel power user. I was right there with you for a very long time, and then I learned about programming and have never looked back. Just there's things that you just are very, 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 very difficult to pull off outside of just straight up learning how to ingest data and be able to process that, whether that's using the Pandas library or something else. You just need programming skills in this day and age, and Python is going to enable you to quickly wrap your mind around solving the actual problem as opposed to dealing with all of the weird programming things that happen if you have exposure to things like JavaScript, where it's a really cool language, but then you get into asynchronicity and things are hard to wrap your mind around sometimes. You think about something like C, where you have to write a lot of boilerplate instead of, solving the problem. Python lets you more or less focus on solving the business problem as opposed to focusing on solving other problems that stand between you and getting to the solution. So super important for actually being able to solve problems. Really is going to help you to, again, develop things quickly. It just makes you this kind of Swiss Army knife of, hey, throw me into whatever situation, I can start developing solutions to whatever problems that ail us, whether that's we need to build a dashboard to report data effectively. I need to build a model in order to be able to predict data correctly, or I need to design some kind of a data entry system that restricts what users can put in, but we get really consistent data out of it. All three of those are really important that Python enables you to solve those problems very effectively.
Interesting. I would say, from what you said, data is like the new oil.
Absolutely.
I mean, like,
yeah,
everybody, whatever industry you find yourself, every industry is trying to acquire data so that they can have better practice or better do their business as well. So what would you say is there any field we don't use, that does not need Python programming, or, what fields out there do you think Python would be very useful? Knowing Python will be useful.
I genuinely can't say there's any field where programming isn't useful in general, but especially when it comes to Python and dealing with data. First off, if your job title has engineer or any combination of the word engineer in it, programming is going to be helpful. I don't care if you're a chemical engineer, a mechanical engineer, an electrical engineer. My background actually is in chemistry. I was a chemist for a while. And then when I was in college, I actually started in chemical engineering. I was doing research in electrical engineering. I work with a lot of mechanical engineers. If you're an industrial engineer, a petroleum engineer, whatever it is, being able to build models or to handle data very effectively in any of one of those disciplines is going to be extremely powerful, because where you might be forced to resolve something as an analytical solution, if you can instead resolve something as being a process or a programmatic or a numerical solution much more effectively, it can allow you to model systems that much more, one, cleanly, but two, with a higher degree of accuracy. But going beyond just that, anytime that you are dealing with any kind of a business problem, whether that's a business analytics issue, whether that's an HR investigation of some kind, whether that's even doing something like accounting or FP&A analysis, Python lets you deal with significantly larger volumes of data, have a lot easier auditing of the processes that went into those data transformations, and just generally understand end to end what you're doing with your data. I think Excel is a very powerful tool that we've all grown accustomed to, especially something like the field of accounting, or again, coming back to that financial side. But when it comes to auditing and understanding how we've historically done something, or understanding how to do essentially the same process that you're doing over and over and over and over, week in and week out, Python is the tool set that you need to be able to be, again, from a business perspective, significantly more effective, but also from a personal perspective, allows you to stop wasting time on these borderline menial tasks that you've done over and over and over again.
That's true. So learning Python is actually beneficial, whatever field you find yourself. Being able to analyze the data you create or you use every day to do a better business is actually beneficial. Whatever field you are, having that programming experience, it's very, very beneficial. And I think going forward, it might actually be a requirement, to have some programming experience to be at the edge of, yeah. So this is really interesting. Thank you so much. I don't know if anyone has any question for Ken before I go ahead. Those from finance or any question?
Yeah, and definitely to echo that while you're waiting on the questions, I do think the field is moving towards programming being just a baseline requirement. Yeah. It probably isn't going to happen as fast as we need it to happen, but because we're moving very rapidly into this field where everybody's dealing with massive volumes of data, you're not going to have time to sit down and, again, going to keep bashing on Excel here, copy and paste the same kind of cells and work with the same kind of formulas over and over and over again. It's becoming a field in which we need to be able to reduce those tasks to mere hours instead of being things that we work on over several days, while still maintaining a very high degree of accuracy. And the only way to do that is to start implementing the ability to conduct analysis at a much higher level. And that combination of programming and statistical reasoning are just going to start becoming increasingly more important for every role.
Thank you. From what you've said, you've actually dived into the next question I have for you. I mean, what kind of jobs are out there if you know how to code in Python?
Wow, I'm gonna toss this one to Sarah first, but I know she's gonna answer a lot of stuff that I probably will. I don't want to take up all the air out of the room here. And Sarah, if you didn't catch.
So this one I actually did a little bit of research because, like I said, I don't code in Python, but because I knew I was coming here, I did speak with some of my connections who are in the area of Python, and also interestingly, while we don't use Python in my teams here in Houston, we do use Python on the data scientist side of the building. So I'm pretty sure that for those of you who are looking for jobs after this, that's one area you can go into. Like what Camden was talking about, anything to do with data analytics. So if you find companies with business intelligence arms, they may have business analysts there who may not know programming. They might be looking for someone who can come in there to write out those dashboards and programs that they actually need to then be able to do more with the data that they've collected over the years. I think a lot of companies are moving toward machine learning. And I think that I'm not sure how in depth you guys are going in this class, but definitely don't stop here. I like that Silva just mentioned earlier that this doesn't end. You have a community to continue building products and projects with other people. Like, keep doing that. Things like the fintech industry, I think that's statistically that's like they're looking for Python programmers at the top, right? Am I correct, Camden?
It's coming further and further down, but yes.
Yeah, but they are still looking for that. And I'm also active in the startup world. As Silva mentioned, I do have some work in the lines of culture. And so I do work with a lot of startups, and there are companies in the fintech industry who still use Python. The other thing is in finance as well. I think that's another area. Just think about it. Anywhere with data, they're going to need you. So that's what I got to say. However, it's not just about data. You can also use Python for web applications. While I have never done Python in a professional setting, I have messed with it when I was still a junior engineer and playing around with technology. I have messed with it, and I have built web applications. And at the time when I was doing research on which technology I wanted to get into, I did write down a list of companies who actually have built their web applications with Python as well. And these are big name companies like Dropbox uses it. I do know that Spotify's backend is powered by Python. So your options are limitless. It's more of doing the research, and if all else fails, ask Google.
Yeah.
You're an engineer, so ask Google.
And definitely, and just to kind of pick up where Sarah left off, nail on the head. Not only are there these kind of data analytics roles, there's the more traditional software development. You can go into a subfield of software development called DevOps, which is really big because this is kind of how we set up our different servers and systems to be able to actually operate across multiple different machines. I can tell you that Netflix had a very long conversation with me trying to get us to build a whole Netflix class. So yeah, like they definitely use it on their backside as well. There is anything in the Internet of Things. So if you're in any kind of a field that deals with sensors or home automation or anything involving interacting with the real world, that's definitely another area of Python use. We mentioned finance, we mentioned all these engineering disciplines. Basically, anywhere that is going to demand some level of automation or some level of analysis, you're definitely going to find Python somewhere along the way. I think that a lot of us do try to kind of lean towards that data analytics or data scientist role, but I highly encourage you to try and find out if you have a background in something else, the way that Silver has a background in chemical engineering. I have a background in chemistry. There's other discipline, or there's other ways in which your discipline might be applied using Python. So for me, one of the things that I found really super helpful was I made a lot of mistakes as a chemist. I like to go really, 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 really fast on things. And so I had a relatively high error rate. So one of the things I was doing was building models to make it so that it would immediately flag if a sample that I was running was out of a level of accuracy. And so if it flagged, I would go back and rerun that sample to confirm it. So when it came to the manager or it came to the client, hey, we've already confirmed this result. I can tell you that, yes, it is anomalous and that we verified that anomaly. So even something as simple as QA and QC can turn into a Python problem that can help you to deliver a higher value product, not only to a customer, but also for yourself. So definitely be on the lookout across any field, because you might find that something that is just an everyday problem for you is something that you can solve through building something with Python.
Thank you all. This is really informative. Yes, Angelique, I agree with you. You said junior bankers at JP Morgan and Goldman Sachs are required to know how to code, definitely. So this buttresses all we've been saying. I mean, it's going to be a minimum requirement. We're just trying to position ourselves to be ready for that era when it finally comes. I mean, you guys are doing great being part of this program right now so that you can be positioned well for it. But yeah, thank you all. This is great. My next question goes to Sarah. Um, Being in the tech field for a very long time and working with software engineers, leading teams, I want to find out what are the possible, I know you've interviewed a lot of people out there. What are the possible interview questions that a programmer or someone that knows Python could generally come across, and how would you say is the best way to answer them?
Okay, so I'm not going to give you an interview question 101 here. If you need like actual interview questions, I suggest looking it up on Google. There are many that you can go check it out, like interview questions and answers. That just think about it. That is the interviewer's way of trying to understand where you are at. Are you a beginner level developer? Are you intermediate, or are you senior? Okay, that's just trying to find out where to place you. So if you don't know something, let's say, for example, the interviewer asks you a question and you're not sure about it, use that as a learning opportunity. Ask them the question back. If you're not sure, say, I don't know the answer to that. Can you tell me what it is? And then you can have a conversation. The other thing is, in terms of the foundation level questions, I would say it's pretty much the same for if you're going in as a junior Python engineer. The questions are pretty much the same. They're going to be asking you questions like things to do with classes, things to do with dictionaries, things to do with maybe functions, objects. This is the same throughout any kind of programming language. It's not just Python. But I think beyond that, right, it's also important for you to be aware that they're going to ask you questions to find out whether you're a good fit in whether they're a good fit in the industry or whether you're a good fit in the company. So those are some kinds of questions you may have to prepare for. They might ask you questions like, why do you want to work here? And so earlier, what Camden was talking about, understanding what your background is, and perhaps, if you have a background in chemical engineering and now you're applying for a role as a Python developer in the chemical engineering field, then you're able to make those alignment points more clear for your interviewer. For example, if you're going into data science and in the past you were doing something entirely different, you might want to talk about that career transition and what made you go into that career. With a little bit more of a long-term view, so it gives the interviewer understanding that you're not just trying it out for fun. Just understand this: if you're doing a career transition, which I think some of you are maybe trying to look into right now. Uh, just know that coming in as a junior or even intermediate role, they really just want to understand that you're a good person. You're not going to take them for a ride, and you're willing to learn, and you learn fast. So if you can communicate that during your interview, you're good. Now that's not to say you don't care about the basics. You do have to know your foundation. So make sure you do your research. Make sure you understand. I think for people who may not have that, perhaps maybe those who didn't go through proper like maybe computer science or engineering training, you might not have all of the uh, literature where it comes to engineering, but there are some things that you would be able to pick up when you learn more about like interview questions and things like that. Make sure you know those things. Those are important. I'm not saying don't care about it, but there is the pluses that you need to be able to nail to get the job. What else? More importantly, projects. So Silver mentioned earlier that you guys have a community going for that. So definitely identify the projects in there that has most resonance to the industry that you're interested in, and join those projects. And that might not be all that you do. You might have more time on your hands, and you might look into open source projects. Those are really good. If you can find open source projects in your where you can provide some value, and it's not even be like don't think that you're going to be able to create like a huge data dashboard for them. Don't think about that. Just think about small things that you can do first, like little commits here and there to help them fix a bug, or maybe they have certain typos. That might be an easier entry into open source coding as well. But all of that should be in some form of a portfolio. If you have capabilities on hand, maybe create a personal website with all the links to the project, or maybe you don't have time or the capabilities to create a personal website. Just have everything in source control. If you have a GitHub repository, there are GitHub pages. You can create a page in there, and in that page you can have a list of all the various things that you have tinkered with. Definitely gives your interviewer an insight into what your life looks like outside of that interview. That definitely gives you plus points. So I'm going to stop there and let you all ask me any other questions. Maybe Camden has something to say to add on to that.
No, you were nailing the head, Sarah. I think you mentioned my two favorite things, which are just know your fundamentals, because I know we're interviewing for people, and when we interview, just straight up, if you don't know the most basics of like, hey, this is how a function works, and hey, this is a constructor for X, Y, or Z thing, or you need to instantiate an object. That's really our level of expectation in a lot of cases of you just know those bare fundamentals. And then the other half is definitely projects. And to me, I think the projects are the single most important thing, because they tell you that, or they tell me as an interview, one, what you're actually interested in. So if you are allowed to go out free reign, nobody's telling you what to do, nobody's telling you what problems to solve, but these are the things that you choose to do. And of the things that you choose, you create quality, well documented, well structured, great and efficient solutions to those types of problems. That tells me the vast majority of things that I need to know about you before you walk in the interview room, but then creates a great conversation piece in the interview itself. So definitely, Sarah, again, nail on the head. Like, those are the things that I absolutely love.
Lovely. And Camden, to add on to that, I think having these projects that you have on hand, that's helpful to get the interviewer knowing more about you before you join the interview. But at the same time, be prepared to talk about them. Like if you have open source projects outside, or if you have personal projects and you can't talk about them, I'm not going to hire you. Like personally, as an interviewer, I don't really ask so much of the foundational questions. I usually let other people on our interview panel take care of that. I like to look more into the application, because I came from a background where I didn't take formal training in development. I mean, I went through a boot camp, right? my personal understanding of this is, as long as you can apply and you're a developer, I will hire you. I don't need you to know like every single thing. I don't need you to describe encapsulation like an essay. I don't need you to do that. But if you can apply it and you understand the real world implications of your code, you have potential in my eyes. So in terms of talking about your projects, I don't know if this is beneficial, but I will share a rough framework that I like to hear from people. Basically, I want to hear about the problem statement. So think about it as this way. If you want to share about your whole project, you can, but I would suggest picking out various features that you're really proud of, that, uh, number one, the code is readable and you really believe that that adds a lot of value to that project. So pick up that feature and then identify what the problem statement was for that feature. Talk about the problem statement, and then I want you to talk about how. Sorry, not I want you to, but you should talk about how you approach the problem. So I would want to know what was the thinking process that took you through that problem to solution. And then later on, you can also talk about whatever challenges that you face, any kind of obstacles, and how you solve that. That is the thinking process that interviewers will be looking out for, to identify whether you're somebody who can be coached into adding the most value on their teams.
Man, thank you guys. This is really informative, like I said. To add to what you guys have said, also there was a time I had an interview and I needed to quickly go through Udemy, like a course in Udemy to just prepare myself for the interview. And I found out I spent hours trying to redo what the person was doing on Udemy. And in the process, I was able to find like some, how do you say, bottlenecks. I was trying to like overcome, because in Udemy, they don't really have like, they will not take you through all of it as it is. I mean, they believe their audience have some experience. So like you should have some prior experience. So I was going through it. I knew what the gaps were because I went through a boot camp. So I knew what the gaps were. I filled up the gap trying to do the same problem again. But when I went for the interview, they were now asking me what was the problems I encountered while working on something. And it was easy for me to just say it because I was practicing at the same time. So we should never fall into the bucket of just watching through a video and just watch. It doesn't help when you go for an interview. But trying to redo what the person did or practice exactly, I mean, see yourself hands-on into it will help you answer some of the interview questions you need to, I mean, it will flow easily. I mean, they quickly catch it when you don't flow easily, really. So yeah, that's what I wanted to add to that. And also, quickly, Sarah, what would you say, or Camden, what would you say a good resume should look like if you're transitioning from another field? Because it's always hard most times when you don't have experience, so much experience in tech, because I had the problem before now. If you don't have so much experience in tech, maybe you're just coming from a boot camp and all your projects have been like in the boot camp, you've not really done any. What should your resume, how should your resume, like a good resume look like when you're transitioning from another industry to the tech industry?
Okay,
Sarah, do you want to start that one off?
yeah, I'll take that one. Okay, so your resume should really just be one page long. Don't have too many pages. I don't. Whenever I interview candidates and it's like 4 pages long, I'm like, okay, -1. It really doesn't need to be too long. Okay, so for people who are making a career transition, that's pretty much what happened to me. You might not want to place too much emphasis on previous experiences that does not have much relevance to what you're trying to apply for. You will keep it in there under professional experience. Don't take it out. Leave it in there, but you don't need to put like that. You know how you usually describe that experience? You don't really need that there. But for things that have relevance to what you're working on, or what you're trying to apply for, definitely expand on it. I would say before you even do your resume, make sure that if you have previous projects or or if you've encountered any open source project and contributed to it, make sure you have that in a list somewhere and keep track of that. In your resume, what you really need is just your name, number, email. You need your address. You need skills. And the reason why you have skills is because for some companies, they put your resumes through bots. So you want them to be able to pick up relevant skills to that job listing. So you at least go through the bots, and then a live person can actually look at your resume. So that's really what that skills section is for. Just put in all the relevant ones to what kind of jobs you're looking for. And then the next section is your education. So if you had gone through boot camps, or if you've gone through like this program, or if you've gone through various kinds of certifications, you'll put it in there, along with, if you've been to college, put in your college information. For some people, they've been through masters, you want to put that in there as well. And then you have your professional experience. So we'll talk about the order later, but professional experience is where you want to put in projects. So if you don't have any specific contract work that you've done in relation to the programming world, you'll want to put in your projects, and try your best. If you're still looking for projects, find projects that are relevant to what kind of jobs you're looking for. Okay, just from my own personal experience, when I did my bootcamp, I didn't just randomly decide on an idea of what my project's going to be. I actually had a construction company hire me and my team to build an admin website for them. So it was like a contract gig, and I was able to use that as a kind of like a reference as well when I eventually went to apply for jobs. So you want to be a little bit more strategic about what you're doing. Do your research. There is a lot of projects out there. I notice a lot of you are asking about open source projects and things like that. Google's really your best friend. Like, try all sorts of permutations and look for various things, and you'll be surprised. Like, you might not have the confidence to join a high profile project right now. It doesn't matter. Just put your name in, and then, you know, what have you got to lose, right? What I've learned working my way up, so I'm originally from Singapore, and in Singapore, I was a manager back in the startup world for ecosystem building. But anyway, when I came to the US, I started off as a junior engineer, and then I worked my way up to now leading teams. But the thing is, what I really learned there is that let go of your pride. Like, if you're planning to do a career change, just let go of the pride and learn as much as you can. Just learn. So if you see a big project and you think that's really beyond you, yes, that could be awareness, and you might be right. But at the same time, if there's some inkling in you, that drive that says, you know what, maybe it is possible, just do it. And if it falls flat on your face, just pick yourself up and try the next thing. Same with job interviews. Don't tell yourself, okay, I'm gonna wait and then interview later. You can even interview now, because you're gonna learn from it. Now, I'm not speaking as an interviewer here, because I won't like it if you do that to me. But just based on personal experience, coming from not being in the programming world to now being in the programming world, I would say just try it out. You know, maybe identify junior roles, you know, and just start applying. You go through the process and you'll learn. You'll adjust your resume. And yeah, I'm pretty sure Silva and Michael, they might have some templates that they can share with you. If not, Google's your best friend too.
Definitely.
But yeah.
Thank you, Sarah. I remember your words. You always say, "What do you got to lose?" I've heard it several times from you.
What's the worst that could happen? Just run it. What's the worst that could happen?
Yeah.
Camden, go for it. I thought you wanted to say something.
Sarah took the vast majority of what I had to say. Like, again, just swing for the fence, let that pride go, and keep applying to stuff. At the end of the day, what's going to really be important is what gets you in front of the interviewers. Sarah, thank you very much for bringing up application tracking systems. They're kind of a pain, and I'm not going to get on my soapbox about HR because we don't have 3 hours to talk about it. But yeah, like you're trying to get past that. Don't do the silly, I'm going to put all of my skills in white text so it'll automatically pass whatever filter. Don't do that. They'll automatically get you thrown out of whatever applicant pool. You want to have a legitimate, do it the right way. I have my actual skills there so that I can get past the ATS system. But once you're past that, a human's going to be looking at it. Know the difference between, in America, a resume versus a CV. I know in a lot of other countries, when we say the phrase resume, it is equivalent to the American curriculum vitae, which is your entire life story, more or less. I can tell you right now, there is no hiring manager in the US right now that has time to read all of that unless they're in academia. On the business side, we want a 1-page, don't go beyond it unless you're applying to a middle or a senior role. Even if you're going for a senior role, those usually cap at about 2 pages. But most seriously, keep it at 1 page, because if you make it longer than that, what I'm going to do when I come to interview you is I'm going to pick something at the very beginning of your resume and ask you about it, and it doesn't matter. I did this to a candidate recently, and he was really upset that I asked him about something 7 years ago, but if you put it on your resume, it's fair game. So don't give me your CV. Give me relevant, recent items that I should care about and want to talk to you about, so that I can ascertain whether you would be a fit for this role. And just as Sarah said, if you don't have projects, go find other stuff to work on. There's a lot of open source projects that if you go into their issues tab, the issues will literally say good first commit or good newcomer issue. So there's issues that are created that are specifically for, hey, I as a senior dev don't have time to go and solve this, but I think it's fairly easy. This would be great for someone who is a junior or a newcomer to the field to go and do. Here's the issue. Please go and make a pull request for that. Personally, I think that the biggest thing, again, is projects. Go solve problems that are related to the field. If you are a chemical engineer and you're saying, hey, you know what, there's not a really good open source project out there for me to contribute to. What's a problem that I have on a daily or weekly, a monthly basis in the field? Let me go write some code or do some project that is specific to that. That's something I can put on my resume. As Sarah also said, hey, I can go talk to X, Y, or Z company that they have a specific problem they want me to solve. I can go internship or be essentially a contractor for that company to build a solution for them and implement it. So all of these things are going to show me as the interviewer a lot of initiative, a lot of what you can do, again, with lower or less defined projects. If you can effectively get things done without a lot of boundaries, when I add in the actual constraints, you're going to be that much more effective.
Ooh, this is a lot to take in, and we're way past time right now. I'll just say, if anybody has any question, and while we're waiting, if you guys have any advice, being the seniors in the industry, for those that are coming in, you can share with us right now. While if any other person has any question, they can throw it out there as well.
Where do we find open source projects? I think I'm going to steal Sarah's soapbox here and say Google is your best friend. But definitely, again, look in, if you have already other work experience, look for things that are happening in your field. So let's say I am all about accounting. So the first thing I'm going to go look through in GitHub for is what are popular libraries that are used in accounting in Python, and I'm going to get 5 or 6 open source projects. I'm going to look through those projects and see, well, what are things that they haven't actually implemented yet, or that they're working on, or is there just a completely unsolved problem in Python or in accounting that I could essentially build something out of.
Thank you, Sarah. Sarah, any advice for the new ones coming into the industry?
Okay. Let me make this short. Self-awareness, understand your capabilities. 2, know what you're trying to apply for. So do your research. And 3, never give up. Just keep going. build your resilience. You're gonna fail, but it's okay.
Failure
I
is
agree.
perfectly fine in this field.
You
Like Sarah, yes, yes.
succeed at the
Nice.
end, but
Said
it's
Sarah should
okay.
be here, right?
The worst that can happen is you run it, it fails the test, you fix it,
Yep.
and you run it again. That's the worst that can
Yep.
happen. It's fine.
It's fine.
Thank you. Thank you all. This is good. Lastly, before we let our guest speakers go, if they want to stay, that is also fine. Someone said he has an experience in telecom. I want to work in Python. How do I put this in my resume?
It depends on what that telecom experience is
Yep.
specifically. If it's on the technical side, this is phenomenal because it essentially means that you understand how network systems work. So that's really what you want to be able to speak as to when you're in an interview is I know how communication systems work and do a little bit more research on how API requests work, how you send or work with a RESTful API or sending any kind of a network request through Python. But I would say that would be a field for you to kind of like specialize in for a little while of just learning how network requests work so that when you come in and say, hey, I know about sending requests back and forth. I was previously in telecom. I got super interested in not only networking, but how we use these networks in order to accomplish other goals. And like that's you have a really nice background to kind of transition into this field because you're really just going from network understanding to more of a technical implementation specialist.
That's a great answer.
Sometimes I have those.
Thank you all. I appreciate Camden. Thank you, Sarah. Thank you. It was really nice to have you guys here. In fact, I'm going to watch this video again to boost, give me a boost. Thank you. I appreciate. This is really a lot and informative, and I appreciate you guys spending time with us to share your thoughts and your knowledge. Thank you. I appreciate. You guys are welcome to stay or go if you want to. But we appreciate. Thanks for having you all. Michael, if you have anything,
Yeah, I want to also say a big thank you to Sarah and Camden. I learned a lot. I took a lot of notes. I'm always continuously learning actually. So I've really learned a lot from information you've shared, the insights and everything. So thanks a lot. And the other ask I can ask of you guys is that when we do our final project, the project team are going to be presenting their work. We'll try to invite you guys. And if you have time on your calendar, we would love to have you come and listen to some of the projects that they have been able to work on, if that's okay.
all right.
Absolutely.
Thank you.
Thanks, Silver. Good to see you again.
Yeah.
Catch you guys later.
Thank you,
Yeah.
Camden. Thanks,
Thank
Sarah.
you, Sarah. Thanks.
So Vishal,
Hey, Michael. Yes.
yeah,
Sorry, we took
Really
a lot of your time, right?
No. This was
Yeah.
good. I also was taking notes and listening to it carefully because these were really good advice. I think it's always good to um, iterate and reiterate over these things. We have heard this from different people, but it's always good to hear them again. And there's always new things. So yeah, no, really liked how the discussion went. I think we utilized the time in the right way.
yeah, thank you.
Thank you.
So with that, I know we have a lot to cover in deep learning today, so I'll let you go ahead and share, and we'll take it from there.
Sure. We'll all be deep learning experts, or at least have our first models ready by today.
Yeah.
That's the plan. All right. Can you guys see my screen and hear me all right?
Hey, I had a question on where we start. When I did that print on that the pie plot, yours is arranged in 3 rows or 3 columns and a couple of rows. Mine is just a single column. I'm wondering if it's how I declared my array.
So I guess I have to look into the code to actually answer that. But the way this one is working is essentially you're defining 3 rows, 3 columns, and you're starting at 0. So you see, if you, so I would go from 0 to 8, right? So that's how the I is defined. So you would go from the first one till the second one till the third one, and this is how we define the 3 rows and 3 columns. I think that's where it might be a little bit different than your code, but we can look at it later if you guys if there's a specific problem. But yeah, if you I can copy and paste this, and you can try and running this on your Google Colab instance, and possibly check if there are some things that you can figure out, or else we can discuss it. Sounds good.
Yeah, sounds good. Thank you. I'll wait till you paste yours and then I'll try it out.
I have pasted mine on
All
the
right.
chat. Yeah.
Thank you.
Yeah, sure, definitely. All right, so we'll pick up from where we left yesterday. So we introduced a problem that we were trying to solve using this quick 1 hour session of machine learning, deep learning using convolutional neural networks. So I'd strongly recommend you guys. It'll be very unfair to try to explain what convolutional neural networks do and how everything happens in such a short time. But please give it a read. There are lots of good videos, good references on the web, which tells you about convolutional neural networks, and it was a game changer for most of the image classification and computer vision problem, because one of the things that the previous neural networks, and we did one of those categories as well, right? We called them feed forward back propagation sort of neural networks. They were not spatially aware. So if you do a dog and cat classification, if you do not have the dog and cat at all sorts of positions, then it was difficult for those networks to really identify a cat versus a dog in a picture. But convolutional neural networks really opened it up, and a couple of years back, I think, um, when was it? It's probably yeah, probably last year or the year before, when three of the people who actually pioneered a lot of these convolution neural networks, Yann LeCun, Yoshua Bengio, and I always keep forgetting the third one, but um, um, yeah, sorry, it just slipped my mind. Maybe I should Google it. Let's just Google it. I don't want to give discredit to anyone. Yoshua Bengio, um, Yann LeCun, and Jeffrey Hinton, right? So these three people, they were really instrumental in a lot of these convolution neural networks, and Yann LeCun actually was the first author for this paper, which had this MNIST classification problem. You should definitely give it a read if you get a chance, and we'll try to do the same thing as they had in the paper with convolutional neural networks. So essentially, we have these pictures. This come from the NIST data set. We have them as a grayscale pictures. These are handwritten digits, and we're trying to classify them into their respective numbers, right? So for example, this one will be classified into a 5. This would be classified as 0. This would be classified as 4, and so on and so forth, right? So that's the problem that we are trying to solve, and we're going to use a very simple convolutional neural network to do this. So I hope you guys already have this part. I've copied this code into the chat window so that you guys can download them NIST data set and get a plot similar to this. Now, what we will do is we'll try to introduce you to this Keras package and the Keras modules of making a very simple convolutional neural network. And that's going to be my new cell. So I'd say building a simple convolutional neural network, CNN, using Keras for MNIST classification problem. Right, so I'm going to import some libraries which I would need for solving the different parts of the problem. And as I go through the coding part, you guys will understand where and what I'm using. So for example, I'm gonna import few packages from the NumPy library, right? So I'll import the mean from NumPy. I'll import the standard deviation. These are going to be used to give some statistical analysis. I'll also use something from scikit-learn. So yesterday, I think I was mentioning this to you guys a lot of time, and then I thought that we should have an example where we can show k-fold cross validation. So it's a way of making sure that your model is trained with with the correct amount of information. It's general enough for any sorts of problems with the same framing, right? So for that we use k-fold cross validation, and especially if we do not have a lot of training and validation data set. So we'll use sklearn.model selection. So that's the module that we're gonna import the k-fold from. So k-fold is essentially the k-fold cross validation. And what else do we need? We need from Keras few stuff. So we'll use from Keras dot utils. We'll import two categorical, and you will see what this particular module does. I'll explain this. Also, for the different layers in the model, we will have to import certain things from Keras. So we'll import from Keras.models. We'll import the module called sequential. This helps us to define a sequential model. From Keras.layers, we will import the convolutional 2D, CONV2D. That's the module that helps you define a convolution layer inside a deep network. From Keras.layer, right? Sorry, I think somehow someone muted me, possibly. So from Keras.layers, I would import max pooling 2D. No problem, that's okay. Next, max pooling 2D, that's another layer that we use. This is more for the discretization and pooling the information together so that you go into a reduced dimension inside the layers. Then we would use from Keras.layers, we'll use another type of a layer which is called the dense layer. So it's essentially also referred as a fully connected layer. It's similar to the one that we use for the feed forward backpropagation type of a network. So it's just a fully connected layer. And to use a dense layer, we need to use another thing which is called flattening the output. So the 2D convolutional neural networks gives you two-dimensional outputs, but you need to flatten them to make sure they go into the dense layer, because that takes a single vector as an input. So we need the flatten from Keras, and the last bit is an optimizer that we will use. So we'll use this standard optimization called SGD, stochastic gradient descent. That's a full form of SGD. Okay, so let's try and import all of these. So while you guys are following along, I'll also try to copy and paste this code so that you can have the modules in your system. So all right, so now that we have it, and make sure that yesterday we touched upon this, make sure you change your runtime and have a GPU in your notebook so that your network trains faster than without a GPU. So GPU gives you an order of magnitude of a compute advantage. Okay. All right, so now we have the different modules, and this is our last hour, and I'm definitely I will try and bring in a lot of our learnings from before. So we had learned a lot about functions in our first few weeks, right? So we had defined different functions. So here I'm going to define a function that loads the training and the test data and makes sure that they have the right shape, right? So that we can use that, we can consume that in the convolutional neural network, right? So define a function to load the training and test data set. Okay. So this is where, because we're going to use this over and over again, it's always good to define it as a function. You could have avoided this, but this is a good practice. So remember how we define a function? We use def, right? And then we will say load underscore data set. That's the name of our function. We'll not have any arguments for the function. It'll just, when we call this function, it should know that we're working on the MNIST data set, and it'll give us the training and the test features, input features, and output labels, right? So this is how we define it. So remember we had this comment stuff. So we wanted to always comment our functions. So we'll say this function loads the MNIST data set from Keras and outputs the train and test data set in correct format. Okay. And of course, I'll put my name in here. And today is 28th of November, right? That's a good enough description. So now what I'll do is this is what we did before as well. We're going to repeat this just because we're writing it in a function. So we'll say train x, comma, train y. This is my first argument, and the next one is the test x, and test y is equal to mnist dot load underscore data. Right? So we did it yesterday as well. So this is how we pulled in the training and the test data set. So this is loading the data. Now what I'll do is I'll have to reshape the data so that the machine knows that there is only one channel. So what this essentially does is basically in a lot of problems you can have both black and white images and colored images. So um, you need to reshape the data such that the machine understand how many channels you have. So if you have a colored image, you'll have 3 channels: the red, green, and blue. And that's or you can have a hue saturation and HSV format, the other format of describing a colored image. So in this case, we'll have just one channel because this is a black and white image, right? So but we'll need to reshape the data set. So, all right, so we'll reshape the data set. We'll say train x is equal to whatever we have as train x, and we will invoke the reshape function for the NumPy arrays. And then we will say, so the reshape takes the shape of the output, right? So what we will do is we'll say train x dot shape 0. That's the number of images that I have in the training data set. Then I know all of these. So we had output the size. So this was the number of images. We know this is a 28 by 28 pixels, right? So we'll say 28 comma 28. That was the initial size, and we'll have to add another thing, which is the 4th dimension, which is 1. So that is essentially telling you that there is one channel in the data set. All right, so we'll have to do this for the test X as well. So these are only for the input features. The output features, you do not need to do this. So this is only for the input data set, the input pictures, right? So I'm going to copy train X in here, and I'll change it to test X, right? Everything remains the same, test X dot reshape, and here also test X dot shape, right? So that takes in the shape of the number of images in the test data set and adds a fourth dimension to it. Okay. All right. So this is about reshape input features of the data set. Let's say. Now, what we'll do is we'll have to do something with the outputs as well. So the labels, right? So we have in the labels numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So these are the different classifications. So now in order to do a multi-class classification problem, there is a common thing that is done, which is called one-hot encoding. So essentially, this is a vector, a binary vector with 10 elements. So if you have the number corresponding to 0, then the first element will be will say it is 1 or true, right? So that's the one hot encoding. If you have the label as, let's say, 8, then you will have the corresponding like the location of this vector, one hot vector, as 1, just to denote that you have a value in that particular class. So one hot encoding is pretty common, and we will use the two categorical module that we imported from Keras utilities. So remember, we had this two categorical that helps us to take care of it. It knows what it needs to do. You just have to put in the input that you put in the input of the class labels, right? And it'll give you the one hot vectors corresponding to those automatically. So we'll do one hot encoding to the output labels, right? So what I'll do is I'll say train Y. So I'm going to overwrite on what I have for train Y. So I'm going to overwrite it with two categorical. So I'll say 2 underscore categorical. And then I'll say the input to this is essentially the train Y itself, right? So we're going to change that into the one hot vector. That's for our first one, train Y. And then we'll also have to do this for our test Y, right? The test outputs also need to be changed into the one hot encoding. All right. So now we have done our pre-processing of the data set. So we have reshaped our input features so that it has the fourth dimension, and we have done the one hot encoding for the output labels. What we need from this function, we all know this, we would return the outputs that we need, right? So we'll say train X, train Y, test X, and test Y. Right? So these are going to be our four outputs from this function. Yeah. So let's execute it. So we now have the function. All right. Now we'll have to do some more pre-processing, and that's why I say the pre-processing part is sometimes cumbersome and complicated. So we will need to scale the pixels. So the way the machine learning algorithms work, and based on the objective function that you're using and the optimizer that you're using, it is almost always recommended to normalize the data or standardize the data, right? So in this case, we will standardize the data such that it has values between 0 and 1. Right now, it has values between 0 to 255. Those are like the dynamic range of the grayscale images, right? So we're going to change that between 0 and 1. So we'll normalize everything. And why this is done, essentially, there's a term in machine learning. You will hear that there's a gradient related optimization problems that happens if you have very, very large numbers, right? So you want to constrain them between 0 and 1 such that your gradients are calculated nicely and you can get the right amount of updates in the weight. So that's primarily the reason why you do the scaling. So let's scale the pixels of the input image between 0 and 1. Okay. So we'll make another function for this. We'll say define a function which is called prep underscore pixels. So we are preparing the pixels, and we'll take two arguments in here. We'll say train and test. Okay. So these are our two arguments. So what it'll do is it'll take what we input as the train, and then it'll it will convert that into this what we call this normalized training image, right? Or the testing image. So you can put your comments in the function. In the interest of time, I'll try to go a little bit quicker here, and I'm avoiding a lot of these comments, but it's always a good practice to have those comments in here. But okay, so the first thing that I'll do for this function is that I'll convert the images from integer format to floating point format, right? So, and why I need to do this is because I'm transforming everything between 0 and 1, so I need all the decimal values, right? So right now it was between 0 and 255 with the discretization level of 1, right? So we had only integer values, but we cannot live with that, so we need to convert it to floating point format. So how do we do this? So we'll say, okay, we'll output another thing which we'll call train normalized. Okay, that'll take in the input training data or the argument, right? And we'll use the function as type to convert the type from integer to floating point with 32 bits. Okay, so that's how we convert into um, the floating point format, float 32 format. Okay, so that's for the input train. This is our input argument. We'll also need to do this for the test image, right? So we'll say test underscore norm. So that'll be test dot as type float 32. So that should convert the test image into the 32-bit for floating point format. Now now that we have this train and test normalized as a floating point format, now we're going to use that to normalize everything that we have in here between 0 and 1 instead of between 0 and 255. So the easiest way to do this is to just divide the whole. So we know these are all positive values, right? We have between 0 and 255. So if we just divide each of these images by 255, then we should get values between 0 to 1, right? That's as simple as that. So that's the easiest normalization that we can do. And there are different functions. We showed that yesterday, right, in scikit-learn that does all these things for you. But I'm giving you an example here that you can have your own functions to do all of this for you. So normalize images between 0 to 1, right? So that's what we are doing here. What we'll say is we'll call in train underscore norm, right? So that's our training image in the 32-bit floating point format. We'll take that same image and divide it by 255.0, right? So that should do our floating point division and give numbers between 0 and 1. I'll do the same with the test image. So test underscore norm, which is the normalized test image, will be the test underscore norm divided by 255.0. Okay. And that's it. This is what we wanted to do with the scaling of the pixel. We should return what we get from this. We will say return training underscore norm and test underscore norm. Okay. That's our second function that does some more pre-processing here. So the first function does the reshape and whatnot, and the one hot encoding. The second function does the scaling between 0 and 1. Okay. All right, now comes to the definition of the model itself, right? So we'll now have the neural network architecture, the machine learning architecture, or the deep learning architecture, and here is where we'll use CNN-based model, right? So we'll define a CNN based machine learning architecture, right? So again, I'll use function to define this. You can do it separately as well. Keras actually is pretty convenient that you do not have to really define the function and the graph. So in TensorFlow, you like the recent version of TensorFlow, you do not need to explicitly mention the graph, but in the previous versions of TensorFlow, you had to do certain things in an order before you can actually run whole computation. So, but Keras is simple in that ways. But we'll still try to go with our framework of defining a function, because it's really neat way of doing this. So I'll say I'll define a function which defines my model. Okay, so defines my neural network model. So it'll take no arguments. It'll just we are not trying to change the architecture, although you could inside this function, but here we'll keep the model fixed. We'll say that, okay, this is the model that we are going to use. No changes to this. So we'll define the model with some of the things that we imported before. So remember, we had imported sequential, we had imported convolution 2D, we had imported max pooling 2D, we have imported dense and flatten. So we're going to use all of these. We're going to use sequential, convolution 2D, max pooling 2D, dense, and flatten. All right, so we'll start off with sequential. So what sequential does is it essentially helps you to build a model stacked up as layers, right? So like the name suggests, it helps you to make a group's a linear stack of layers into a Keras model, right? So you're going to build this architecture where you're stacking layers on top of another. It's almost like building a Lego structure, right? So you're making bricks, you're putting bricks on top of another. So that's how you build the machine learning model. So that's why sequential helps you in doing that, right? So once you have the model defined as a sequential model, the next thing that you would have to do is to our first layer would be a convolution layer. Okay, so it's a 2D convolution layer, and to do that, what we do is we will add on this model a new layer, which is a convolution 2D layer. So this was another module that we had imported, right, from Keras. And this convolution 2D layer you'll have to define the number of the different parameters for the convolution 2D. So the two main things are the number of filters and the kernel size. So what is the size of the filter, right? And how many filters you want. So this is where you are taking an image and you are projecting it into a very, very high dimension. That's where the whole power of computation and getting all these nonlinear relationships in classification really comes into picture. So we'll make a decent sized model here for this task. So we'll say we'll have 32 filters, 32 convolution 2D filter, and each filter will be of size 3 by 3. Okay, so we know that our images are 28 by 28, so you cannot use any number which is as big as 28. But in this case, we are trying to capture all the small features in the input image. So we are using a very small like filter. We are saying that the filter size has 3 pixels by 3 pixels, and this filter will you know um, go through the entire input image and will extract all these features that's needed for classification, right? So this is the first thing. The other thing that you need to do is essentially um, to define the activation function. So let me actually check my parenthesis. So okay, so all right, so I have the width and strides and everything. I'll keep the same, padding I'll keep the same. What I'll do is I'll define the activation function. So activation function is essentially what introduces the non-linearity in this process, right? So if you did not have this activation function, if you do a linear activation function, then essentially you do not get the benefits of the non-linear optimization. So I'll use an optimization function which is called ReLU. So ReLU is essentially rectified linear unit. It's you can almost imagine, or it is actually a linear function only truncated at 0, right? So you'll get any value which is greater than 0 will be retained as is, and any value which is less than 0 will be truncated at 0, and that essentially makes the function nonlinear. It's a very effective function for a lot of machine learning algorithms. All right, so the other thing that we need to do is we need to initialize the weights for these filters that we defined, right? So, and these are initialized randomly, but there are different sophisticated ways of initializing these weights, and you would if you read machine learning literature, you will find that a lot of focus is on this, because it really matters how you initialize this weights. And if you do not initialize it correctly, you will end up with wrong optimization and wrong, wrong results. Not wrong results, or rather, I mean, it will not truncate as nicely as you would, or converge more nicely as you would want. So in terms of kernel initializer, I'm going to use something called he_uniform. So it essentially uh, samples the weights from a uniform distribution, and this is a paper by somebody's last name, whose last name was He. You can read the paper if you want to get more details of this initializer, but this is essentially drawing weights from a uniform distribution. Okay. The last thing that is absolutely necessary that we'll have to kind of specify is the input size, or the input shape of the images, right? So in this case, we know our images have very are standard. They have 28 by 28 by 1 as their sizes, right? So 1 is the number of channels. So remember, this is why we had to pre-process the data such that we have this added dimension. So we have our inputs as the number of images, comma 28, comma 28, comma 1. So you just give the last 3 dimensions of those of the input that's required in this convolutional neural network. Right, so that's about it. Now we will close the parenthesis for model.add. I think this should be sufficient, and this essentially, this has added the convolution layer to this. Now, once you do convolution, you're going to a higher dimension, so you wanted to shrink it, and a way to do it is using max pooling, and you can read about it as well. There are lots of literature on there. So I'll add another layer in here, which I'll call max pooling layer. So it essentially pools your data and shrinks the data size as well. And max, the word max is because it's taking the maximum value of this, based on the size of the filter that you define. So I'll say max pooling 2D. That was one of the module that we imported, and we'll have to define the size. So the size of this max pooling 2D would be 2 by 2. That's what I'm going to use, right? Okay, so now we have the convolution layer, and followed by it, we have a max pooling layer. The third layer that we will define is essentially a fully connected layer. But in order to go into a fully connected layer, we'll have to first flatten the outputs from this 2D model, right? So to do that, it's very simple. We have a module for that. So we'll say model.add, and we will add a flatten module, okay, with its default parameters. So it'll just flatten everything in here. The next thing that we would do is we would add a dense layer to this. So that's essentially a fully connected layer. So now I'll put a dense layer with the number of neurons as 100. Okay. So and again, this can be a hyperparameter that you can test. But in this case, I think this can be a good starting point. So we'll say the number of neurons as 100. We will put the activation function again as a nonlinear activation function. So we'll say that this is equal to ReLU. Okay, and what else do we need? We need we need another initializer here, kernel underscore initializer. Is equal to he underscore uniform. All right, I've lost connection here. Yeah. All right. Anyway, so okay, so that's our next one. And then the final layer is going to be another fully connected layer, but this one has an output that has 10 neurons, and these are essentially the probability values that we would have, right? So if the first neuron has a probability of 90%, then we'll classify that as number 0. If the second neuron has a probability which is the highest amongst all the neurons, then we'll classify that as 1, and so on and so forth. Okay, so in this case, by design of this problem, we will say that the last layer is a fully connected layer with 10 neurons. And in this case, we will use an activation function which is called a softmax activation function. So essentially, the reason for doing this is because we want this last layer to output probability values, and softmax is a function that goes between 0 and 1. So you'll only get values between 0 and 1 if you go through this function. So that's why it's a softmax activation in this case. All right. Now that we have this model defined, now we have to specify the optimizer that we are going to use. So all the machine learning, deep learning methods, they are non-convex, right? So we do not have a convex optimization scheme. We rather use a stochastic or a global optimization scheme. And in this case, I'm just going to use the simple SGD module. So we'll use the stochastic gradient descent, and we will define a learning rate for this. So this essentially defines how fast your weights are going to change in between the iterations. So that's LR equal to 0.01. Again, another hyperparameter that people would test as they train these models. And then I'll also mention a momentum of 0.9. So I want the momentum to be pretty high in the start. All right. And once we have all of this, we would have to compile the model together so that, all the gradients and everything are, calculated correctly. And we'll also have to define the loss function that we're trying to minimize, right, in this case. So to do that, we'll say model.compile. That's how we compile a model that we have defined. We will say that the optimizer that we're going to use is defined by OPT, right? That's what we defined in here. The next thing that we have to mention is we'll have to mention the loss function. So there are different loss functions that are inbuilt in Keras. And for any of these multi-class classification problem, we use a loss function, which is called categorical cross entropy. Okay, so we're going to use that. Again, this is a very standard one. You can read about it. Essentially helps you to get, the classification problems loss functions defined. Okay, cross entropy would be the one. And finally, what I'm trying to look at is not just the loss, the minimization of the loss, but I'm also going to look at the accuracy of the predictions, right? So one of the metrics that is here built in Keras is what is called accuracy. So that actually tells you, okay, how good the model is doing. So how accurate are the predictions? Okay, and that's about it. So once we have this, we'll return the model. Okay, that's our function. So I know I do not have a runtime here, so which is not a good news because I have to open another new notebook. I'll copy, paste few things in here.
Have you tried the reconnect on your tab?
I did. It's not allowing me to do it, but let's see. Oh, it did. Oh, wow. Good. Thanks. I think, yeah, I clicked it once, but it didn't. But now it has given me the resources. This is great. Yeah, awesome. Thank you. All right, so let's see if we can execute this function. Yep, now we have the function. All right. Okay, so now that we have a function, we would try to evaluate the function, and we'll try to use the k-fold cross validation to do the evaluation of the function of the model, right? So the next part is actually to evaluate the model, and we'll do it in a very automatic way here through the function evaluate a model using k-fold cross validation. Okay, that's what we're going to use. So we'll say define evaluate model, right? So that's the name of our function. And in this case, I'll take few inputs. I'll take the data, the input features. I'll take the output labels, right? Data y, and I'll also give the user the ability to define the number of folds that they want. So okay, so I'll say number of folds. And remember, we could define a default value in the function. So I'll say that, okay, if this is not defined, we will use the default value, and I'll say the default value is 3. Okay. All right. So now what we'll do is we'll define few things. We'll say we'll try to because this is a k-fold or a 3-fold cross validation, we'll have to keep a tab of the scores and the history of the model. So I'm going to define 2 separate variables as scores and histories, and this would be 2 empty list. You guys should all be familiar with this. These are 2 empty lists that we have. Okay, so this is initializing the scores and the histories just to make the computer know that there are 2 empty lists that you need to fill in. Next, we would try to do the cross validation. So to do that, we will use the module called kfold, right? And this is again how you define a k-fold. It's in here. So you have to define the number of splits and whether we want to shuffle it or not. So it will do, if you have shuffling as false, then it would it will not shuffle the data while you're taking the different sets or different splits, right? So we'll keep it as true. So what we'll do is our number of splits is our input argument and folds, right? And for the shuffle, I'm going to turn it to true. And because I want to reproduce the results, I'll say the random state should be equal to 1. All right. Now that we have the different folds defined, now we will go through each of these folds, take the data from each of these folds, and then evaluate the model, and then output the scores and the histories for this, right? So this is what we call enumerating the k-fold splits. Okay, and for this I'll use a for loop, right? Because we're going through the different folds that we had generated, right? So we'll say for the train underscore ix, which is the ith fold input features, and the test underscore ix, that's my the input features for the training and the test data, the ith fold, in k fold, which is my fold definition in here, dot split, and in here I'll argument the data x. So what it does is it's essentially creating the different folds based on this input data x, and would separate them into training x and test x. So these are the cross validation scheme that we have. So it's a beautiful way of doing this. I mean, it's just one line of code, and you get the splits of cross validation. Okay, so we have the train ix and test ix that will come in these different folds. Now, what we will do is we will initiate the model that we had defined. So we will say model is equal to our function define model, and we will use, we do not have any arguments for this, right? So we'll just use open and close parenthesis. The next thing is we will try to get the data that we want based on this k-fold cross validation that we have. So what we'll do is we will get train x, train y, test x, and test y. So those are our 4 data sets that we need. And how do we get them? We'll get it using the indexing based on this train ix and test ix. So these are all the indexes of the k-folds that we have. All right, so we'll say data x, and in parentheses, because this is a numpy array, it will take all the inputs of the indices. So we'll say train underscore ix, and similarly the next one would be the same indices, but for the data y, which are the labels, right? So still train underscore ix would be the indices. Next one would be data x test underscore ix, which are the test data indices, and data y would be our test underscore ix again, which is our test indices. Okay, so this essentially gives you, so this one was giving you the indices of the different folds that you created, and now this guy actually gives you the data, the train x, train y, test x, and test y. All right, so now what we will do is we will now try and fit the model. So how we will do this is essentially we'll call this as history, which is our empty list, try to fill that in, and we will do it using model.fit. Okay, inside model.fit, what we will need is we'll need the input data, the input features, and its corresponding labels, train x and train y. We will have to define how many iteration or how many epochs. Epochs is a common terminology that you will hear in machine learning literature. It's essentially the number of iterations. So we'll want 10 iterations because we have some compute limitation. I want to show you some results at the end of this. We'll also define the batch size. So batch size essentially defines the batches that would go in for the training all by itself, and this actually takes into account the parallelization that we have. So it takes account if you have multiple cores and the GPUs and whatnot, it does it more efficiently. So we'll take a batch size of 32. 32 is a very recommended size because 32 is also the bit size as well. So um, yeah, and then we'll also define the validation set here. So we'll say validation underscore data is equal to, and here I'll mention test X and the label test Y. Okay. And there's another keyword in here, which is verbose. Verbose essentially means that it'll start, giving you at each epoch what's the loss, what's the accuracy that you're getting. But I'm going to, suppress that by saying that verbose equal to 0, because because we're doing multiple folds, right? It's going to just make the output window very, very big. But you can try with verbose equal to 1 just to see what it gives. It's just going to output at each epoch what's the loss that it's getting. Okay, so that's fitting the model. And then we will do the evaluation, which would be, so evaluating the model, the first argument of it, I do not need it. So I'll just leave it at underscore. That's a way of defining a temporary variable. And the second one, I need that. So that's accuracy. And this is equal to model.evaluate, and using test X and test Y as our data. So in my case here, I'm having the validation data and the test data set as the same, right? So because we're not doing any hyperparameter optimization in this case, so it's actually pretty okay to do this. And again, the verbose should be equal to 0. All right, so after this, I'll try to print what is the accuracy after the models are run and have been evaluated on the test data set. So I'll say, this is a specific format, print statement format with 3 decimal points. I'm going to output the accuracy multiplied by 100.0. So that's in percentage, right? So that's going to be the accuracy that'll be outputted at the end of each of this evaluation. Okay. And now we want to store all these scores because we want to do some more diagnostics with this. So we'll try to append the scores together. So scores.append. So you should remember this. This is what we learned in week 1, I think, with the list append function. So we will do append all the accuracies that we get from the evaluations out of each of these runs, right? So we have it inside the for loop. It'll run for the number of folds, and we'll have accordingly the number of accuracies stored inside. Same with the histories. So we'll try to get the histories dot append, and in here I will append the history. Okay. And what I need as a return from this whole function, so I will exit out of the for loop, which is going into the next white space, and I'll say return the scores and the histories. Right? So it'll do all these calculation inside this function, and we'll just return the scores and the histories from this. Okay. So this is going to be the crucial one. So hopefully this runs fine. Okay. Yep. It did run as per our what we wanted. So now there'll be some more stuffs that I'll do, and in the interest of time, I'll just copy and paste some codes in here, and we can discuss things in detail, and I'll try to give you a high level idea of what we are trying to do here. So what we are trying to do is we are trying to plot some diagnostic learning curves. So learning curves is essentially at the end of each epoch, how is the accuracy increasing, or how is the loss function decreasing, right? So it is going to plot the loss function for the training data set and for the validation set, right? So which is the test data set. So we're going to plot that, which is the cross entropy loss. That was our loss function, categorical cross entropy. Remember, that was the loss function that we used. And it's also going to plot the classification accuracy. Okay, so it's going to output the accuracy for the training data set and the validation accuracy. These are all stored in the history. Okay. All right, let's try to run this as well. Okay, so this looks good. Um, and the final one that I need to do is to also have a way of summarizing the results out of the k-fold cross validation, right? So for that, I'm going to also incorporate another function in here. And let me actually paste them in the, yeah, thank you. I was just going to do that. So I'm going to paste the diagnostic learning curves function and summarizing the plot model performance function in the chat window. So you can see that this is going to give you a whisker plot, or what we call as the box plot, and you will see what it does. It essentially, it'll give you the extent of how the mean and the standard deviation of the scores or the accuracy for the different models actually vary as we vary the different, as we do the different cross validation. All right, so let's execute this. This is done. Now the final function that we'll have to define is to actually run all of these different functions that we have defined before, right? So this is how we do it. It's a very neat way of doing things. So you can identify very clearly which function is not working if you write a code in this kind of a structure. So this final function is a final function to run the previous functions. Okay, so we'll call this define as run test harness. Okay, just to harness all the stuff that we've done before. Okay, so the first thing that we'll have to run is to the load data set function. So we'll say train x, train y, test x, test y is equal to load underscore data set. And this doesn't take any. So so because I did spend some time in writing a comment about this, so you know that this is a function that I defined, and this loads the data set and adds the extra dimension to the input features and converts all the output labels into one hot encoding vector. All right, so once we have that, we will use the outputs of train X of the input features, right, from the first line, and we will normalize them. We'll scale them between 0 and 1. Okay, so in order to do that, we have another function. We have done our hard work in here. Train X and test X is equal to prep underscore pixels. That's our function, and this takes in the input image and input training image and the input test image, right? So that's the two, and it'll output the normalized ones. Okay, then we have another function which we defined, which was evaluating these models, and we're outputting the scores and the histories. Remember, that was the last function that we defined. So we'll say scores comma histories is equal to evaluate underscore model, and this takes in the train X and the train Y, the input features and the labels, right? So now in order to plot the learning curves, we have another function which we call summarize diagnostics, and this takes in the histories as the input, right? So we'll take that, and then we will say the final one that we want is to summarize the performance, and that takes in the scores. Okay, so that ways we have used everything that we have outputted, and this is essentially how you'll have to think about these functions a little bit, but once you go into this coding mode, these should come in pretty naturally to you. Okay, so that's it. So the function returns all of these things by default, because some of these functions have plots and stuff as well. So we just do not return anything from here, and we will now, moment of truth is we'll run this run test harness function. Okay, fingers crossed. Seems like it's running. So if you do not have a GPU, this might take a lot of time. So you can already see that you're starting to use a lot of the compute in here because remember the number of input images were 60,000, I think. And the test images are also 10,000. You're making some plots in here, so it might take some time. So, all right, while this kind of does what it's supposed to do, any questions? Oh, here you go. We have the first accuracy. So this is the first accuracy that we are getting is around, where did we output the accuracy? Let me check. Yep, here you go. So we have executed this function pretty nicely. So the first accuracy that we are getting is around 98.6%. And then it has reduced in the next k-fold cross validation 98.53. And we'll have to wait for another one, I guess, because we're using, I think, 3 as our k-folds cross validation. But if you guys have followed along, this is if you have not tried machine learning, deep learning before, then this is your first deep learning model. And here you go. You have the different plots as well. So this is the cross entropy loss, and you can see that the loss is decreasing in the training and the validation sets. The training set decreases faster, the validation set decreases slower, but we do not have a reversal. So which means that there is no there's a variance bias problem which we look at that is not happening in this case. So we have the losses from 10 different epochs. Same with the accuracy. Accuracy is just the opposite of loss. So accuracy would increase. So the initial epochs, the accuracy was very, very low. But as you went ahead and did your 8th or 9th epoch iteration, the accuracy almost went into 100%. All right, so and then what else do we have? This is essentially the box plot. So what it is telling you is that you have a threefold cross validation. The errors in here vary in between 98.5% to 98.75%. So this essentially gives you a lot of confidence on your model as well, and then you can do something more with the models and get an idea. If this was a huge range, right, then you know that your model is not very stable because it's depending on the validation data set that you're using, that the accuracy is either small or large. All right, so I'll end it at that, and then I'm seeing that there are a couple of errors that people are getting. So I think somebody mentioned about the print statement. So this is a print statement that I used, and I'm going to copy and paste this into the chat so that you can see if there is something specific with its parenthesis or the single quotes or whatnot, or maybe it's the white space. So that might be a problem. What is this saying? Test.py not found. So instead of using test X, test Y, maybe you have used test somewhere. Maybe it's trying to, it's maybe looking at that and giving that error. So maybe you can, if you have no further questions on what we have gone through, maybe we can look at few of these errors in details. But before we do that, let me, I know we are almost at time, and this is all I had. That's it. I'm done what I had to tell you guys. So now it's your time to tell me whether this made sense, whether what you thought about it, and what errors you're getting. And by the way, like always, we will send these notebooks to you guys, and you can run it and see where exactly the differences lie. And Google is always your best friend, right? So. Yep. Over to you, Michael. Maybe if you had any comments. Or...
Wow. Michelle, thanks a lot. This is great. This is really great. Thanks a lot for walking us through this. You do this so seamlessly, Vishal. How long have you been doing it?
been a while now, but
Wow.
yeah, no. Once you get used to it, it's very good, and Keras is actually pretty neat. And once you get used to Keras, you can go into even more sophisticated packages like TensorFlow and PyTorch. They give you more flexibility and stuff like that. But yeah, Keras is definitely one of the good ways of starting, learning all of these.
And I just wanted to sound this to the participants, like, okay, Vishal is doing this very seamlessly, but I bet you the first time you did it, Vishal, it wasn't so straightforward, right?
Oh,
It comes with practice. So don't feel intimidated with this. You get your hands on it, you practice, and you see yourself getting better with every practice. So, you face it, we send the videos, you have materials. Google is also your friend, and you have opportunity to do some things in the projects as well that could help enforce this knowledge. But face it and just practice and get better every time, you know, by the day. So are there questions? I want to see if there are questions on this subject before I wrap up today with some information about next steps. I'll give a minute or two for questions. Wow, it looks like Vishal, you really delivered this so well. Like everybody.
or I didn't deliver it at all. It could be both ways.
Yeah, I think you did excellent work.
Yeah. By the way, while we wait for questions, there is a school video, which is an interaction of the same model that we did, a little bit sophisticated. It tells you the different layers of the convolutional neural network, and you can draw stuffs in here, and it tells you what happens internally in the different layers in the different 2D convolutional neural networks, and what the machine is looking at in order to make this final prediction and whatnot. But this is all based out of the same things that you guys did here. So yep, this is on YouTube, I think. Yeah,
Can you post it on the
right.
chat? Thank you, Vishal.
Sure. Let's
Uh,
stop sharing at my end, and
uh,
I'll leave it at that. Yep.
yeah, you can stop sharing. Okay, so if there are no more questions, I think this wraps up the training course. Thank you, everybody, for staying with us all the way. We started this a month ago now, and I see a lot of participants stayed with the course, and we walked through everything from functions to NumPy, pandas. Like Vishal has really walked us through a lot of some of the tools we need, to be able to, be confident to work more examples on our own and develop the skills. And Vishal, thanks for introducing us to machine learning, and also deep learning is a hot topic in the modern world. So we're going to be building on those learning, as we continue to practice. I think the final thing is just the projects that we are going to be providing to you guys. And that project will be sent out. We're still kind of finalizing it right now. So we hope to send it out by the end of today. The plan is that you can form groups, maybe groups of 4, so that you can work in collaboration, because in the outside world you're going to be working a lot of these things together in collaboration. So we'll send a list of projects, about 4 projects that you can pick from and form a group. And also, if you want to work individually as well, it's also fine. But in addition to the 4 projects, we're also open. If you have a project you've been working on your own, and you want to, build on it and showcase this as well, that is also fine. And the plan is to have we call it a demo day. If you've been to one of these computer boot camps for tech, they always have a demo day where the participant can present or share the project that they've worked on, their final projects. So we're looking at, and I want to sample the opinion of the audience here. We're looking at the Saturday, the 12th of December, or Sunday, the 13th of December, to give sufficient time to work on this project. We can also do it sooner, but I feel like if you have the project tonight and we're doing it next weekend, that's just a week and people have other work. So what do you guys think? If you can put your date, I would have put a survey so that we can see it in real time, but what is your preference for the final project? Okay. All right, I think we got the answer. So I see overwhelmingly people are picking the 13th, a few 12, but I think 13th is what most people have preferred. So we'll make it at the 13th. So we're going to tell some of the people from industry. Hopefully we can bring Camden. Is a great guy, a lot of experience. You can see all the things he's been doing with Netflix and the other people. So we'll bring him in and we'll also bring in other people from industry. Sarah can join us, and we'll try to bring in other support to come and watch you do your share the work that you've done, and hopefully you can make some connections as well in the process. So stay tuned. We'll send this information to you at the end of today, and then we can get going. Then in the course of doing your projects, feel free to form a group. You collaborate in the Slack channel. You can ask questions. If you need support, Vishal is always there to provide insight. I'm there. And we also have some other mentors that would be on Slack channel to guide you on the way. But also Google is your friend. Feel free to reach out to Google. The projects are going to be something that is completable within the time frame. So it's not something you do for like 6 months. It's something that is reasonable. So difficulty level should be intermediate at most, so that we just keep it limited to some of the concept that Vishal has been able to pass across to us. So thank you everybody for this is the end. We at the end of the demo day, we'll also be giving a certificate of completion for those who have completed their week 1 and week 2 project, and also this final project. So you stay tuned to receive that at the end of the demo day as well. Silva, I don't know if you're online, if you have anything to
Yeah,
add.
I just wanted to add that thank you all for your participation. Thank you, Visha and Michael, for taking us through this 1 month. I mean, it's been great, and I'm actually overjoyed after every class to see, I mean, the way it's going and the response. Thank you all, I appreciate. I just wanted to also add that I only have like 2 resume that needs to be looked at, and we'll get the feedback within the week or at most on the 13th. Thank you. So if you still have resumes you want to send to me, just send it and so that I could add it to the ones I have. But yeah, I'll give you back guys feedback by either the end of this coming week or on the 13th. Thank you and thanks a lot. Thanks, Rochelle.
Thanks everyone for being a great audience. I hope I didn't kill you guys.
Vishal, you did an excellent job. I want to give you a round of applause for this 1 month of training, a lot of knowledge that you've been able to impact on people. Thanks a lot. Great job. Really great job. I think this is
Thanks
best of the
everyone.
kind. Yeah.
Yeah, definitely appreciate it. I see some of you guys have reached out to me on LinkedIn. So, I mean, feel free to drop in a message. Please mention IT experience if you can, if I do not respond back to you, because sometimes, yeah, it just gets overwhelmed with a lot of requests. So, but I'll try my best to get back, well, once I get some time. And you guys have been an awesome audience.
Thank you, Vishal. Yeah, we'll reach out to some of you if you want to leave feedback, and just because we continue to evolve and grow in this, there's going to be a lot of other free courses coming up next year, and we'll provide list of those courses and schedule soon when we have them all sorted out. But we'll reach out to some of you for just feedback and on what you think about the course and what you've learned as well. So that will really help us as we continue the journey for IT experience. Thanks to Silver for organizing this, all free, courtesy of IT experience. And thanks to Vishal for his time, volunteering his time for putting all the materials together and delivering such an amazing course. Thank you. And thanks to also Sarah and Camden,
Super
that joined
amazing.
us today. Amazing people. And thanks to you all, the participants, man. I've not seen a class with such, level of participation, such energy, staying. Yeah, I've seen some other Python training that within the first day, you see a lot of people just quit and say, oh, this is not for me. But you guys hang in there from functions and we go deeper, but you guys stayed with us. And now we even got deep learning. And I see people, usually in deep learning, everybody sign off after 10 minutes, but you guys stay.
Magician, Vishal.
I don't know how you kept people staying focused in deep learning. So thanks a lot.
Don't let the feedbacks percolate to me. Once I was giving a training in one of my previous jobs. Somebody told me your voice is very soothing. It puts me to sleep. I didn't know whether it was a good feedback or a bad feedback, but I just took
Yeah. So feel free to look us up on LinkedIn, Silver URL. I'll put my name as well. You send your LinkedIn invite. We hope to continue the community as well. We hope to keep interacting with you guys on Slack, and we'll be sending, information, on industry information that is upcoming as well, training course, seminars, things that would keep you in the community. And the most important thing, I think, like Sarah and Camden says, practice. You have to practice and practice. I was watching a video on the NBA and see LeBron James with all these nice 50 points in some of the games. I promise you, if you watch that game for 200 times, it doesn't make you a basketball player. The only way to be a basketball player is to get the ball, go to the court, and start throwing. And the more you throw, the more you get better. That is how I see programming. You have to really live it, breathe it, do it, love it, and you would grow. But you cannot just grow by watching a video or by just listening to a class. This is just the beginning. We're scratching the surface, but I think you have the tools to be able to grow. Yeah, practice, practice, practice. Thanks, Darlington. Darlington. So with that, I know it's 7 minutes past time now. Thanks a lot. I will let you guys go now, but stay tuned for the project and let's form the group quickly so that we can get going on the project. Thanks, everybody.
Thanks. Bye.